Hey there. So today we're going to look at how to find a GCF. You'll remember from your elementary days, GCF stands for greatest common factor. The definition: in a multiplication expression, the quantities being multiplied together are called the factors. Example, 42 equals 6 times 7, therefore 6 and 7 are factors of 42. 3x equals 3 times x, therefore 3 and x are factors of 3x. The greatest common factor is the greatest number that is a factor of all the numbers in an expression. So, first example, find the GCF of 21 and 15. So you can see here we have listed out the factors of 21 and 15, and you can see that the one they have in common is 3. There's another method that I like to use with this, and it's basically a division. I'm going to write it over here in this margin. I'm going to write 21, skip a little space and write 15, and basically make an upside down division. And then I ask myself, what goes into 21 and 15? Well, 3 does. 21 divided by 3 is 7. 15 divided by 3 is 5. Will anything go into 7 and 5? No. Therefore, 3 is the GCF. Whatever we have on the outside of our little upside down division sign is actually the greatest common factor. So on this do one, we have 28 and 42. Now obviously the bigger number that you start with, the faster this will go, but let's say we just think, hey, these numbers are even, let's divide by 2. 28 divided by 2 is 14, 42 divided by 2 is 21. Will anything go into those? Yes. 7. 14 divided by 7 is 2, 21 divided by 7 is 3. Will anything go into 2 and 3? No. So on the outside here I have a 2 and a 7. So I multiply those together and get 14. That means 14 is the greatest common factor of 28 and 42. So I want you to write down, how would you teach this to someone? What would you tell them? The next examples, we're going to throw in some variables. So to find the greatest common factor of w squared and z to the fourth and u squared w to the fourth, we've expanded. How many w's are there? There are 4 z's, there's 2 u's, there's 4 w's. What do they each have? They each have 2 w's, so they have w squared. So the GCF would be w squared. So the key to this when dealing with exponents, the GCF is the smallest of the exponents. So for example, if you're looking at x squared and x to the fifth and you want to find the GCF would be x squared. Because they both have an x squared, the x to the fifth actually has more though. So whatever the smallest one that they have in common. Do one. 120 a to the third b squared and 90 ab to the third. We're going to shorten this a little bit. How about we make this, instead of 120 and 90, let's make it 12. And let's make it a to the third b squared and 90 a b to the third. Not 90. I said I was going to make 9. So let's change that. Sorry about that. 9ab to the third. Just to make it a little shorter. Okay, same process. Let's do our upside down division. You can probably look at 12 and 9 and know what goes into those. 12 and 9. Well, 3 goes in. 4 and 3, nothing else is left. So 3 is the biggest number that's going to go in there. And now we need to look at the letters though. We can do the same process with the letters. I could put the letters here with the 12 and the 9, and I'll do that later, but for right now I'm going to write them out. A to the third, 1, 2, 3. B squared, 1, 2. and then I have an a and then a b to the third. Well, what do they have in common? They each have one a and they each have two b's. Therefore, my GCF I have an a and a b squared, so 3ab squared. So if you look back at these, the smallest exponent on these a's was a 1. That's their GCF. When you compare b squared and b to the third, the smallest exponent is a 2. That's what they both have. So let's look at a couple of these on the back. So now when we factor polynomials, the first step is to find the GCF. So for example 3, you have 5a plus 35. So the GCF is 5. Well, I know some of you can look at that and go, yeah, that's right. And some of you are going, how did you get that? Well, let's look at my little upside down division and see what happens here. Okay, both of those numbers end in 5, so I know that I can factor out a 5. Factoring is kind of like dividing, taking out. If you read this over here, you can take it out, you're dividing. So 5a divided by 5 leaves you with an a. So basically what you just did was 5a divided by 5, and you're left with an a. 35 divided by 5 is 7. So now what happens, whatever's on the outside, whatever's on the side of your upside down division sign goes on the outside, and whatever's on the bottom, that leftover part, that goes in some parentheses. So this would be your answer to factoring 5a plus 35. If you multiplied those back together, the distributive property, you would get 5a plus 35. So factoring and doing the distributive property are actually opposites of each other. In the middle of this page, it shows you another example way to do that problem. Let's do a couple of these down here. We're not going to do all these because some of them have way too many variables in them. So let's look at number 1. I've got 2x to the third plus 4x squared minus 6x. Well, you can see that all of those numbers are even. So let's take out a 2. And so basically we're going to divide everything by 2. So 2x divided by 2, 2x to the third divided by 2 leaves you with x to the third. 4 divided by 2 is 2. You've got an x squared. 6 divided by 2 is 3x. Now, do you notice that all the terms have an have an x in there? So we're going to take out an x. So if we take an x away from this one, that'd be x squared. Here's how you can check as you're going. X squared times x is x to the third. If I take an x out of the 2x squared, that'll leave me 2x. X times 2x is 2x squared. If I take an x out of the third one, that's going to leave me with 3. 3 times x is negative 3x. I can't take anything out of a 1, a 2, and a 3, or an x squared, an x, and a 3. They don't all have x's. So our answer would be this. This number on the side, that's our GCF. So that's 2x. I multiply those together. Whatever I had left on the bottom of that box, I'm going to write in parentheses. So there's my answer. 2x times x squared plus 2x plus 3. If you multiply this back together, you should get the question you started with. Let's look at number 3. You have a negative 6c squared minus 3. So first thing I hope you notice is there's not a variable in the last one, so you can't take out a variable or you can't factor out a variable. So really, what we're looking at is what goes into 6 and 3? 3. So remember, we're dividing again. What's negative 6 divided by 3? Negative 2. Okay, I'm not taking out any c, so that's just negative 2c squared. What's a negative 3 divided by 3? A negative 1. Nothing will go into 2 or 1, so our factored answer is negative 2c squared minus 1. There you go. Number 5. Crazy. Let's look over at number 4 for a second. Number 2, 4x squared y squared and 16xy. Okay, what's going to go into 4 and 16? Hopefully you notice 4. If you notice a 2, then it's just going to take you longer. When I divide by 4, I'm going to get x squared y squared. 16 divided by 4 is 4xy. Now, you'll notice that I have x's and y's in here, so I can factor those out. I have x squared here, but here I only have an x. So if you think about that, that means they each have an x. and there's a y squared and a y, so they each have a y. So I'm going to take out 1. xy times xy, x squared, y squared. If I take out xy on the second term, that's going to leave me with 4. So that answer would be, remember you multiply this over here, 4xy times xy plus 4. A lot of x's and y's and 4's there. If you multiply this answer back together, you should get what you started with. You undo the factoring by doing distributive property. We're going to skip 4. Let's look at number 6. Let's pretend there's no g there. Let's take out that g. I don't like it. You can't do this when you're doing problems. I can do it when I'm doing examples, okay? That's just the rule. Teachers get special privileges. I know y'all probably know that already, right? So, what goes into 3 and 12 and 30? Let's try 3. If I divide by 3, I have a k. If I divide 12 by 3, I have a 4, k squared. If I divide by 30, I'm going to have a plus 10k to the 5th. So now you look at it, you see you have a k in each term, so you have to take that out. We have to factor it out, which means we're dividing. K divided by k is a 1. You have to put a 1 there. If you don't, your answer won't work. Negative 4k squared divided by k, so we're taking 1k out, so that gives me 4k. 10k to the 5th divided by k, we're taking 1k out. That leaves me with 10k to the 4th. Again, multiply what's on the sides. That's 3k. What's left inside? 1 minus 4k plus 10k to the 4th. Okay. If you need to see these done factored out, we can do that. If you want to write out, basically expand what you have. So for instance, let's do that on number 2 back up there since it's not very long. So if you think about 4x squared, y squared is, I'm going to go and write 4 because you know that 4 goes into 16. So that's 4 times x times x times y times y. And then 16xy, that's 4 times 4 times x times y. What do they have in common? They each have a 4, they each have an x, and they each have a y. 4xy, that's what was on the outside right here. What's left over? xy is left on the top, so that's what comes in first, and then a 4 on the bottom. So I prefer the upside down division. It just makes it simpler for me. You may like it where you expand it. It's really up to you. Sometimes the ones where you expand it get very long, so I would suggest giving the upside down divisions process a try and see what happens. Okay, that's just a basic introduction to GCF. The assignment, I've worked out a few problems on the assignment for you, so hopefully you can get through those. We'll talk about them in class as well. All right, that's it for now. Thanks.